differentiation. So an explicit function express one variable directly in terms of the other one will be like that. Just all the normal functions we have, y equals xy plus cosine x. So y is all in terms of x. But sometimes it's inconvenient or impossible to make an explicit function to make y to be the subject. So for example, if you look at those two, it's very hard. Let's say it's hard. Let's say it's not impossible for the first one to get y in terms of x, but it will take a long time. And same as the second one. So such relationships can be considered as defining one variable as an implicit function of another one. So basically it's a mix of x and y's in both sides of the function. So it's not y in terms of x or not x in terms of y. Last two lessons we talk about dx dy. When x is in terms of y, we can find dx dy and flip it to make a dy dx. But in this situation, it doesn't work because y is not in terms of x or x is not in terms of y. That's why we introduced the idea of implicit differentiation. Okay, implicit differentiation. So before we do implicit differentiation, I just use the space to talk about chain rule. Okay, so it's the same thing as chain rule. So if I give you something like d dx, okay, d dx of 2y squared plus 2, what that means? If y is a variable, x is variable as well. Not treat y as a constant. So I want to differentiate the function 2y squared plus 2 regarding to x, right? According to x, like differentiate to x. But, well, like y is a variable, like you can't treat y as a constant in this case. So what I can do is, so this is the key idea of implicit differentiation. You can have a look. If I cross out the dy here, it's exactly the same as before. And why I'm introducing that? Why I'm using the chain rule here? Because I can differentiate the left hand side. Okay, I can differentiate the left hand side. So the left hand side is just 2y, 4y, sorry. Yeah, this one is just 4y because I want to differentiate 2y squared plus 2 according to y. Okay, so d to y. So that is just 4y. But like I need to times with dy dx. Okay, so the top function will equals to this one. So this is actually equivalent to that. And what's dy dx means? What's dy dx? Why we find dy dx? Gradient. So it's just 4y times the gradient. Okay. This is the key idea of, well, I will tell you a quicker way to do it later, but this is the key idea of the implicit differentiation. So we'll take example to talk about that. So if we look at example 18, I will pick one, easier one. Okay, let's pick this one. C. Okay, let's do C. So C is basically all rational functions. Okay, now let's have a think. I want to implicit differentiation still wants to find dy dx. Okay, so my goal is find dy dx. Okay, my key goal is to find dy dx. So what I will do here is y is a variable, x is variable. Okay, do not treat y as a constant. Y is not a constant. Y is something changing. X is something changing. So what I will do is actually d dx everything. This is really slow, but like you're not going to do this like later on. So I'm just showing you the idea of it. So I will d dx everything. Or you can say d dx both sides. So I'm differentiate both sides according to x. What we can see from this is if you only have x involved, it's really easy because d dx of 5x squared is just 10x. And here is just 10x. What's going on here? Okay, that's 10x. What's ddx of 7? 0. So this one will be 0. Okay, and this one. Okay, we have done this, we have done that, and how about that one? So I also ddx of 3y squared. So what I can do here is actually I will change that to dy of 3y squared. But at the same time, I need to times dy dx to make it equivalent to the top line. Okay, it's the same idea I just introduced, like for the right-hand side. So what we have here is 6y times dy dx. Okay, do not worry about the dy dx, just leave the dy dx. That's the thing I'm trying to find. Okay, so dy dx. Okay, the tricky one will be this one. If I want to differentiate this, what rule I need to use? Quotient rule, right? So what is quotient rule? What's the bottom? Y squared. Have I differentiate anything in this step? No, not in this step. Okay, and then what's on the top? Y times diff of 2x, right? So that's just 2. So it's the, I'll just write it's d dx of the 2x. And minus what? So 2x will stay the same and times d dx of y, right? D dx of y. So there's two diff. One is diff of the top and one is diff of the bottom. And diff of the bottom is differentiation of y. Okay, so let's simplify that. What's d dx of 2x? What's d dx of 2x? 2. So it's 2y here. And what's d dx of y? It's 1 dy dx. Because you differentiate d dy of y times dy dx. So this will be converted into d dy of y times dy dx. So which is 2x times dy dx. And then over y squared. Okay, that's the second term. Okay, what's the first term? The first term is 6y times dy dx. Because I write like very detailed, so that's why there's not enough space. You shouldn't write this much, like when you actually do these questions. And then minus 10x, that's the third term, and that equals to 0. Okay, that's all the workings. So this is the actual thing. So 6y times dy dx minus 2y minus 2x times dy dx over y squared minus 10x equals to 0. So simplify that a little bit. 6y dy dx minus, we have 2y over y squared, that's 2 over y, plus 2x over y squared times dy dx, minus 10x equals to 0. Let's rearrange the function a little bit. Okay, what I'm talking about here is the theory. Okay, why is like that? But like when you actually do the question, it's not that hard. Okay, so do not stress out now. Like it should be much easier than this. So I will leave the dy dx term on left hand side. So what we have is 6y plus 2x over y squared. That many dy dx. And there are other terms to the other side, so it's 10x plus 2 over y. And the amazing thing is we can make dy dx on its own, like on the left hand side. So dy dx equals to 10x plus 2 over y over 6y plus 2x over y squared. You can't leave the answer like that. You need to times y squared on both top and bottom. It's not that hard, just times every term by y squared. And also you can divide by 2 on everything. That's a 5, that's gone, that's a 3. Okay. This is like the theory why it's like that, why we find dy dx by this way, like how we can find implicit different functions. But the key idea, I'm not sure if you find the like pattern. The key idea is if you meet x, you just differentiate as normal. And if you want to differentiate y, you diff y as normal, but you add the dy dx at the back directly. Okay, so that's the rule. Anything wrong with my calculation? Which part? I think it's not the answer like I calculated last time. Which part is not right? Yeah? Is that a plus sign above or is a plus sign above? That's a plus sign, then that's a minus sign. 2xy squared. Then which sign will change? This sign will change. And then this will be a minus sign. 6y, that's a minus. And that's a minus. That's a minus, that's a minus. Copy the sign wrong. Is that right now? Copy the sign wrong from the top line. That's a plus. All right, now we try another one. Let's try this one. Okay, so do not think about d, dy, those kind of things. We differentiate as normal. Okay, now we want to diff cosine. Okay, diff cosine. What cosine will become? Minus sign. So it's a minus sine of 2y. But you also need to differentiate the 2y. Okay, so you also need to differentiate g dash x minus sine of gx. So you also need to differentiate that part. That's 2 times dy dx. Okay, so it's 2 times dy dx. Now we want to differentiate the sine 3x. Well, that's normal. That's just a 3 cosine 3x. When you meet x, like it's just as normal. And equals to a half. You want to differentiate x times y. What rule you need to use? Product rule. So we will diff x first. So that's 1. So you get a 1 times y. Now you will keep the x. You differentiate y. What do you get? 1 times dy dx. Yeah, it's the product rule of x times y. See, that's much easier. You don't need to write the d dx, d dy thing a lot of times. You just, when you differentiate y, you put dy dx after. So what we will have is minus 2 sine 2y of dy dx. You know what I'll do? I'll times the 2 on both sides. Times 2 on both sides. And what we have here is a y plus x times dy dx. Which one? I times 2 on both sides because I want to get rid of that half. No. So think about what's cosine to x? What's the differentiation for cosine to x? Minus 2 sine to x. So I get exactly the same thing, just change x to y. So it's minus 2 sine to y. You just differentiate inside. You just differentiate the inside, that's 2. And then cosine becomes minus sine, so that's we have a minus sine to y. Okay, so it's g dash x, f dash gx. So you only diff it once. So you only diff the y to y once. So that's the 2. And then cosine becomes minus sine. And then you put the 2y in it. So it's exactly the same. If cosine 2x, we'll get to that. Cosine 2y will be that as well, and times dy dx on it. Yeah. So what we will have here is where there? Okay. That's correct now? Okay. Have I diff it? Yeah, I diff the 3 already. Okay, so that's your answer. Okay, just rearrange it to make dy dx to be the subject. Okay, do the last one here. All right. Can we do the last one? So what we did, well, we can put this one on 149 outside, and differentiate of x squared is 2x, and nothing wrong with it. It's differentiate x. And we can plus the 1/9 here. Okay. Now I'm going to differentiate the y minus 1 squared. We can do the right hand side first. What's differentiate the 1? 0. I always see students get problems here, like they forgot to differentiate the constant to make it 0. They still keep the 1 there and then like can't get the calculation right. So that's a 0 there. Now let's think about how to differentiate that one. Yes? 2? Yep. So 1 times dy dx. Correct. So you differentiate the inside. So differentiate y got 1. But because you differentiate y, you will get dy dx at the back. Okay, so it's gx to the power of n is n gx n minus 1. So that's the first two terms, n gx n minus 1. And then differentiate the inside. So differentiation of the inside, you diff y. So it's 1 times dy dx. Okay. And you can rearrange it to make dy dx to be the subject. Probably I will times 49 times 9 first on both sides, and that becomes 9 times 2x plus 49 times 2y minus 1 dy dx. And then times 0 is still a 0 on this side. So times 49 times 9. So trying to get rid of the denominator before I rearrange it. So we have 18x plus 98y minus 1 dy dx. So 18x equals to 98 1 minus y dy dx. Dy dx is 18x over 98 1 minus y. So if I want to find dy dx, the values, I need to know the coordinates like 1, 2 or 3, 5. I need to know the coordinates. Otherwise, there's no place to set both x and y values. Y minus 1. Oh, you be careful, be careful. Okay. That's implicit differentiation, and I can show you that on the calculator. Last thing is the CAS. So if you go to the CAS, go menu, calculus, and you keep going to the end, there's an implicit differentiation. So it's E here, implicit differentiation. So click on that. And we can put some function in, let's say 2y squared plus 3x squared minus y equals to 5. Let's say, for example, this question. And then I will put, well, this is the equation I want to find the implicit differentiation. Put comma x, comma y here. Then comma x, comma y. Just press enter. That will be the dy dx result. Comma, because it's two variables, you tell in the calculator the variables x and y. So comma x, comma y, and it will be dy dx. Okay, it will be dy dx. So it's minus 6x over 4y minus 1. Menu, number 4, and keep going down to E. So 4E, yeah.